Fourth grade, we are on lesson 29, using a protractor. We are on page 302. We're going to do 302 and 303. But first I want to talk to you about protractor. Okay? So, if we look, here it is. And when we get back to school, or when you're in school, you will have one provided for you. I feel very confident. But this is what a protractor looks like. This right here in the center is where you're going to line up your vertex every time. And if you look at, here is your 0 mark, here is your 180 mark. Out on the outside, it goes 10, it goes 5, 10, 15, 20, all the way around to 180. And if you look here on the inside, you've got 10, 15, 20, all the way to 170, okay? So you have to be really careful when you're measuring angles. I think I've told you before, I always like to look at it first and see, is it a right angle? Is it a straight, obtuse, or acute? And that kind of gives me a guide as to what numbers I need to focus on with the protractor. So let's look. It says, Kara drew the angle below. What is the measure of the angle? Well, I'm going to look at this right now, and I'm going to say, without doing anything, that I know it's not a right angle, because if it was, it would be more like more like a square, like an angle on a square. Okay, so I'm going to look at this right here, and I'm pretty sure it's obtuse. It is bigger than 90 degrees, larger than 90 degrees. So I'm going to look, because right here it tells me if it was a 90-degree angle, it would look something like this. If it was a straight line or a 180-degree angle, it would look like this. So it is somewhere between 90 and 180. Well, I guess y'all probably read that. It is obtuse. So let's look down here. Let's use a protractor to measure the angle. And it's going to show you, first you line up your vertex, just like I told you, and then you're going to line this up with one of your rays. You know, ray has a vertex and then a line that does not end, and it will show, it'll have an arrow like it could go on forever. So you're going to line it up with your 0 or 180, that they're both the same, they're both the straight line, and then you're going to look. And if you look right here, if you look really hard at your book, you can see there's a 60 and 120. There is a 50 and a 130. So if I was going to look at this and I wasn't sure, it would either be a 55-degree angle, if I'm just looking at the protractor and not thinking about it, or a 125-degree angle, to be exact. Now, I know that it is obtuse, so it can't be 55 degrees. It has to be the 125. So, if I'm estimating, and I don't want to be exact, which I'm not a real big fan of that, but anyway, it would be, could be 120. I'm going to go ahead and say it is 125, because that is what the protractor said. Now, why must you line up the protractor's center point with the vertex of the angle? The vertex of the angle must be the same as the vertex of the circle that the protractor is part of. So let's write that. The vertex of the angle must be the same as the vertex of the circle. That the protractor is part of. Okay. Number 4, if you line up one ray with either mark showing 10 degrees or 170, instead of either mark showing 0 or 180, how would it change which mark the other ray points to? It's going to make it 10 degrees wrong. It will be off by 10 degrees. You don't want that. So line up either mark showing 0 or 180 with one ray. Which mark does the other ray point to? So we're talking about the problem we were doing just a moment ago, and we discussed it over there. So it was either, it lined up to either 55 degrees or 125 degrees. Which number of degrees is the measure of the angle? Well, we've already decided it was 125 degrees. And how did we know that? Because we eyeballed it, or we looked at it and decided that it was obtuse. It was an obtuse angle before we measured it. I cannot stress to you enough how much that is going to be helpful. If you'll go ahead and decide what type of angle it is before you start measuring, you will save yourself a lot of heartache. Okay, so let's look at these problems. Phi draws a flag, or pi, whatever his person's name is. What is the measure of the angle on the right end of the flag in the drawing? So I'm going to use my protractor. I'm going to line it up, put my point, my vertex right there in the little circle, making sure it's all lined up. And I know that this is smaller than 90 degrees. So when I come over here and looked at my protractor, I could either choose 150 or 30. Well, since I know it's less than 90 degrees, I'm going to choose 30 degrees. It is a 30-degree angle. Then let's look at the x-ray that Dr. Ortiz did. So I'm going to, once again, first thing I'm going to do is make sure I get my protractor lined up, put this at the vertex where two lines or rays meet. I'm going to adjust a little bit up there. Now I know that this is obtuse. Before I even put my protractor down, I knew it was an obtuse angle. So I'm going to choose now, I'm going to look and let's see, let me make sure I get this lined up right. And it is pretty close to a 150-degree angle. So let's review. First thing I would do is decide whether it is, what type of angle it is. Make sure that you line up your vertex and line up your ray with either 180 or 0. They're both that straight line or straight angle. Then I'm going to look to see, and I'm going to make sure that I follow along and know how to read it. 10, 15, 20. This is 10, 15, 20. I'm not just going to assume the measurement. I'm going to look at where it is between, unless it falls directly on the tens. All right, class, I'll see you later. Have a great day.